And next, let's look at example 1.66. Example 1.66. So the question asks us to solve the equation cos x plus pi by 3 equals to sin x for the range of negative pi to pi. Negative pi to pi. So, as usual, we are going to solve the question using, as long as you are solving trigonometric equation, right, we are going to use the 4 steps. But before we start to use the 4 steps, we always try to make things in the format of like, there will be I'll give in a general way. In a general way, right, trigo and the angle, I don't care what the angle is now, okay, and a number I'll just put as k. It should always look like this pattern before you try to do the 4 step. Before you do the 4 step, you always try to make things in this manner, in this format. For example, what is this trigo and then bracket x plus minus alpha equals k? What is this? It means that it has to be in this manner. For example, sine x equals to 1 over 2. This is in this manner because there is trigo, there is angle, there is a constant value there. For example, like cos x plus 3, not x plus 3, x plus 30 degrees equals to sec 3 over 2. So this is also in this manner, trigo, angle, constant. Or like tangent x plus 60 degrees equals to 1. So it's also in this manner. If there's a constant here, we will bring it to the other side. Tangent x plus 60 degree equals to 1 over 2. We always try to make things in this manner, where there's always the trigo, angle, and also there's a constant value there. Before we try to do the 4 step that I just mentioned. Okay, so in this case, obviously it's not in this manner yet because it's trigo, angle, and another trigo. So there's like 2 trigo there. So what are we going to do is, we are going to try to solve and simplify and try to make it in this way. I don't care what trigo it is. It can be cos, sine, tangent, whatever, as long as it fulfills this. It is in this manner basically. So it's easier for us to solve, and then we can use the 4 step. Okay, so how are we going to make it in that way? So first, what I see is angle plus angle. I mean, inside the angle there is something plus something. When there's something plus something, it's almost similar like the compound angle formula, A plus B equals to cos A cos B minus, because for cos plus it's minus, you need to remember that. Okay, and then sine A sine B. You gotta be careful. You gotta be careful with the negative sign here, because for cos plus it will be minus. If it's minus cos A minus B, then it will be plus here. So you have to be careful with it. So it's minus. Okay, it's minus. Okay, students always make careless mistake here because they will just add. So it's minus. Okay, with this compound angle formula, we can apply it on here. Cos x plus pi over 3. Cos x plus pi over 3, which is cos A, which is x, cos B, which is cos pi over 3, minus sine x and sine B, which is sine pi over 3, equals to sine x. In this way, it's more easier for us to solve because we know that cos pi over 3 is a constant. Sine pi over 3 is just another constant. So to find out what's the value, you simply just have to change your calculator in terms of radian for the angle and find out what is cos pi over 3. So cos pi over 3 is 1 over 2. So it can be written as 1 over 2 cos x. Okay? And sine pi over 3 is sec 3 over 2. Sec 3 over 2 sine x equals to sine x. Okay? So you can see that we are almost not really in the manner like the trigo, angle and constant manner, but we can further simplify. You see there's sine here and there's also sine here, so we can combine because they are like a like term. They're almost like a like term. Okay, like there's x and x, just that this is sec 3 over 2x, this is 1x. Okay, so they are considered as like a like term. Okay, just treat it like a like term. So 1 over 2 cos x equals to sine x plus sec 3 over 2 sine x. Okay, so if you were to add the value up, it will be, you can just treat it like this. I'll factorize the sine x, so I'll left with 1 and sec 3 over 2 in there. So 1 plus sec 3 over 2 is 2 plus sec 3 over 2 cos x. Okay, 1 over 2 cos x equals to sine x. So the 2 and 2 can just simplify. So I'm left with cos x equals to 2 plus sec 3 sine x. Okay, and it's still not in the manner like the trigo, angle and constant manner. So if you notice that I can actually bring this to here and I can make it in terms of sine x over cos x, and I also can bring this to there to make it in terms of 1 over 2 plus sec 3. So this will give me tangent x. This will give me tangent x. So it's in the trigo, angle, constant manner. So 1 over 2 plus sec 3 equals to sine x over cos x. This is basically tangent x. So I'll write it at the left hand side. So we managed to make it in terms of the trigo, angle, constant manner. So we can use the 4 step now. First step, basic angle. The basic angle is tangent inverse 1 over 2 plus sec 3. So because we are using in terms of radian, right? So make sure your calculator is already in radian now, because I mean before this you already use it because this is radian, right? In terms of radian also. Okay, so tangent inverse 1 over 2 plus sec 3 will be pi over 2, pi over 12, pi over 12. Second, determine the quadrant. So since this is a positive constant, means we are going to choose where it's in the positive region. Second one, tangent positive, it will be at obviously the first quadrant and the third quadrant as well. So this is pi over 12 here and also pi over 12 here. Okay. Third is new range, but it's already in x, right? And then the range given is also x, so the range is, you just follow the question given, negative pi to pi. So the last one, you solve for it. So x equals to the first one, which is pi over 12, pi over 12. The second one, which is 180 degrees plus pi over 12. 180 degrees means 1 pi, because we know that 360 is 2 pi. So half of it will be pi, 1 pi. Pi plus pi over 12. Pi plus pi over 12. So the answer will be pi over 12. Oh wait, sorry. Oh, the range given is from negative pi to pi. So this is not allowed. Sorry, I didn't. Okay, we need to be careful with the pi, with the range given, because the range given is from negative pi to pi. That means this is not accepted. Okay, I need to be careful with it. So this is not accepted. Oh, but we can take another value which is from here, which is the clockwise direction, from here to here, because we are allowed to have range from here to here and range from here to here. This is positive pi and this would be negative pi. Okay, this is positive pi, this is negative pi, but we can't take this. This is like pi and plus another pi by 12, so this already exceeded the range given by the question, which I didn't notice just now. Okay, so yeah, we can't take this. Okay, we need to take this and also this. So what is this? What is this? This is basically like, okay, be careful, when we go on the clockwise direction it will be negative. It will be negative because we usually take in this way, this direction, the counterclockwise direction. So if we were to take here, it will be negative already. So the range given is negative pi, but the value, the answer, the solution is negative pi, and I reduce it by pi over 12. I reduce it by pi over 12, so it's like not so negative, not as negative as negative pi. Okay, if you get what I mean, it's not as negative as negative pi, which means it's negative pi and I reduce the negative, which is plus pi over 12. Because previously we always take in this way, we will call it as pi and further extend by pi over 12. But in this case, we are going in the negative direction and then we are reducing it. When we are reducing it, you can imagine it's like we add more value so that we reduce the negative, we reduce the negativity. So we plus pi over 12 instead of further minus, because we go lesser to the negative side, right? We plus pi over 12. So our answer will be pi over 12 and negative 11 pi over 12. This is our answer. Okay, this will be example 1.66. And let's look at example 1.67. Solve the equation sine 3 theta plus sine cube theta equals to 0 for 0 to 2 pi. Okay, solve the equation. So you notice that everything is in terms of sine theta, right? Which is good, which is easier for us to solve, but this is sine theta, sine 3 theta. This is not sine theta, it's sine 3 theta. I've never ever seen sine 3 theta before. So how can I further make it in terms of just one sine theta instead of sine 3 theta? Because sine 3 theta is not the same as sine theta. It's like the angle is 3 theta. So we need to use the compound angle formula. Sine 3 theta can be written as, okay, we know that 3 theta is a combination of 2 theta plus 1 theta, right? And from here we can use the compound angle formula, which is the sine A cos, the sine A plus B will be sine A cos B plus cos A sine B. That formula, compound angle formula. So sine A cos B plus cos A sine B. This is the compound angle formula. Okay, apply the compound angle formula here. So we can also further simplify, because you see right now there's another problem. There's in terms of sine 2 theta and there's cos came out, so it's like very not so easy for us to solve. So we need to further simplify it. We just want sine theta, because as I said before this, we always try to make things in terms of just one trigo. It will be easier for us to solve. So let's try to just simplify things to make it in terms of just one trigo, which is sine, because you already have sine here. Okay, so sine 2 theta, obviously we cannot do anything. There's only one formula for it. 2 sine theta cos theta. Okay, I just expand using the formula of the double angle formula. And cos 2 theta, wow, there's so many formula for cos 2 theta. But as I said, I just want everything in terms of sine. So I just use the formula, which is 1 minus 2 sine square theta multiplied by sin theta. Okay, so I just expand using the formula. There's 3 formula for cos 2 theta, but I'll use the one which is only in terms of sine. And you notice that when I expand this, I will get cos square theta. I will get cos square theta. And I already mentioned before this, whenever you see cos square theta or sin square theta, you have to be very, very sensitive, because we can always apply the Pythagorean identity that cos square theta can be also written as 1 minus sin square theta. Okay, and I expand sin theta minus 2 sin cube theta. So this will give us 2 sin theta when we expand, and sin cube 2 sin cube theta plus sin theta minus 2 sin cube theta. So 2 sin theta plus sin theta will give you 3 sin theta minus 2 sin cube theta minus 2 sin cube theta minus 4 sin cube theta. So this is how we find a formula, because I don't memorize the formula for sin 3 theta. There's way too many formula for us to memorize. We don't memorize the formula. Okay, but for sin 2 theta, cos 2 theta, all this, I mean, it's easier for us to memorize because you have already been using it since form 5, form 4, your SPM level, so it's easier. But sin 3 theta, we are not going to memorize it. There's way too many formula for us to memorize. Okay, so don't memorize it. Okay, just prove it. Okay, so with this, I get the formula for sin 3 theta, and I'm going to apply it here. I'm going to substitute there. So sin 3 theta is, okay, just use a different color, 3 sin theta minus 4 sin cube theta plus sin theta equals 0. So sorry, it's sin cube theta. Okay, it's sin cube theta. Okay, sin cube theta. So minus 4 plus 1, it gives us minus 3 sin cube theta. Okay, and I'm just going to divide everything by 3. Okay, sin theta minus sin cube theta. More easier for us to do it. Okay, and I'm going to show you one very common mistake by students, because they always do this in exam, which makes them to get penalty and deduct their marks, to not get full marks. They will always do this sin theta, and they move the sin cube theta over there. And then they'll be like, oh, sin theta here and sin cube theta here, I can simplify, and I'll get 1 equals to sin squared theta. And then I will further do like square root both sides and things like that. No, you can't do this, because you are cancelling out one of the solution for sin theta. You can't do this, because as you cancel sin theta, right, you already cancelled another solution for this whole equation, which is like you just deduct your mark, because you do less work. You can just imagine that way, because we are trying to solve for the whole equation. If you like do this to simplify the sin theta, you are cancelling out the solution, so which is not correct. What we're going to do instead is we are going to further factorize, because you notice that there's sin theta and sin theta here. We will further factorize it instead of simplifying things, move it over. Okay, just simplify it by factorizing. So you get 1 minus sin square theta. Okay, I know 1 minus sin square theta is cos square theta, but it's okay. We are not going to make it in terms of cos square theta. It's okay. Okay, what we are going to do instead is, this is the pattern of a squared minus b squared. If you notice, because 1 can be written as 1 squared, 1 squared is still 1. So 1 squared can be written as 1. 1 can be written as 1 squared. It's the same. So it can be further factorized using the a squared minus b squared property, which is a minus b, a plus b, right? So sine theta 1 minus sine theta 1 plus sine theta equals to 0. So it's either sine theta give us 0, or 1 minus sine theta give us 0, or 1 plus sine theta give us 0. So we got this, this, and this. Sine theta equals 0 is very simple. Just sketch out the graph. For 0 to 360, right? For 0 to 2 pi, yeah. 0 to 2 pi, which is 0 to 60. Just that it's in terms of radians. So this is 0 to 2 pi. So when sine 0, it will be at this, this, and this. Sine theta 0, which is 0, pi, and also 2 pi. This is 0, pi, and 2 pi, correct? And this is sine theta equals 1. Sketch out the graph also. I mean, I already sketched it here, so no need. It will be at, this is pi. This will be half of pi, which is pi over 2. And also here. Oh wait, sine theta equals 1. There's only one value for it. So yeah, theta equals to pi over 2. And sine theta equals to minus 1. This is simple. Negative 3 pi over 2, because negative 1 only here. This is negative 3, positive 3 pi. Why do I write negative? It's 3 pi over 2. Yeah. Okay, so the answer, theta equals to, I'm just going to arrange in ascending order. 0, pi by 2, pi, 3 pi over 2, and 2 pi. Just add everything up. Take everything. So this is the solution for example 1.67. It's a little bit challenging because we need to first write sine 3 theta in terms of sine theta, just like theta without the 3 theta. And let's look at another example. Example 1.68. So this example, right, involve the factor formula. The factor formula, which is not so popular in the recent syllabus, the syllabus that's after 2013. Okay, never came out before for the factor formula. So but I'm still going to explain in here. So the question asks us to solve the equation for 0 to 180. I'm going to just choose one question to solve, which is sine 3x minus sine 2x plus sine x equals to 0. Okay, so the factor formula, okay, if you still remember, the factor formula is we have to add the trigo together, like sine plus sine, sine minus sine, cos plus cos, and cos minus cos. We don't have formula for that previously. Before learning the factor formula, there's only like cos and then the angle A plus B, or like cos angle A minus B. There's no like cos A plus cos B. There's no formula for it before we learn the factor formula. So now that we learn the factor formula, just use the factor formula for this. So if you can see, right, the factor formula for any factor formula, there's 4. Okay, you will always have p plus q over 2 and also p minus q over 2, right? If you still remember the factor formula. If I just take for example sine A plus sine B, okay, it will be 2 sine A plus B over 2 and cos A minus B over 2. This is the factor formula for sine plus sine. But notice that if I have to add this, right, you see this is our A. If I just take this as our factor formula, okay, this is 3x, this is 2x. if I add things up, this is the p plus q over 2, it gives us 5x over 2. If we minus, this will give us x over 2. So it's a little bit not so nice for us to solve in terms of just odd, like the function is over 2. But instead, if you can choose this and this as a pair, 3x plus x over 2, this will give us 4x over 2, which is 2x. 3x minus x over 2, this will give us 2x over 2, which is x. See, everything's in terms of x, 2x. It's not x over 2, or it's not 3x over 2. It's very hard for us to solve because of the angle. It's hard for us to simplify in the end. So instead of gabong these two things, we will take this and this. We won't combine this and this. Instead, we do combination for this and this. It's just easier for us to simplify in the end because of the formula a plus b and a minus b over 2. So I'm going to rearrange it. Sine 3x plus sine x minus sine 2x. The sine 2x is easy because we know the formula for sine 2x. But sine 3x, we definitely have to use it one. Okay? Which is we just combine using the factor formula. So let's further simplify first. Sine 3x plus sine x using the factor formula on here gives us 2 sine 3x plus x over 2 cos 3x minus x over 2. This is the factor formula. Minus sine 2x. Okay, so this will give us 2 sine 2x cos x minus sine 2x. Oh wait, sorry, it's in terms of this equals to 0, this equals to 0, equals to 0. Okay, so what I'm going to do is I'm going to factorize, because I see sine 2x and sine 2x. I'm going to factorize the sine 2x. So I get 2 cos x minus 1 equals to 0. So it's either sine 2x that is going to give us 0, or cos x equals to 1 over 2 that will give us 0. So sine 2x equals 0 means what? You can just imagine, because 2x, right, that means there will be 2 cycles in the range of 2 pi. There will be 2 cycles in the range of 360. But right now we are using 180. Okay, I'll just sketch out first. There will be 2 cycles. In 360, 2x means 2 cycles in 360 degrees instead of the normal 1 cycle. This is 2 cycle. 1, 2. 2 cycles in 360. So sine 2x equals 0 is at where? Here, 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 and here. But notice that we only want it in 0 to 180, right? We only want from 0 to 180. So the one after, 180 will be at here, half of it. So this one going to ignore. So we're going to take 0, 90, and 180. This is 90. This is 0. And for cos x equals to half, for this we're going to do the 4 steps. The 4th step, which is the basic angle equals to cos inverse half. Cos inverse half, which is pi over 3. Oh, we're using in terms of degree, right? So pi over 3 will be 60 degrees. Okay, 60 degrees. This is the first step. Second step, sketch out the quadrant. 60 degrees for cos positive will be here and here. Okay, new range. The range given by question is from 0 to 180 lah. So just follow the question. So we are not going to take this lah. We are only going to take this instead of taking this both, this and also this, because this already exceeded 180. So the answer is just x equals to 60. So final answer, x is equals to this plus this, 0, 60, 90 and 180 degrees. So with this you can try to do the question from checkpoint 1.14.